Swayam Prabha. Digital India. Educated India.
Welcome everyone to our online NPTEL course Environmental Chemistry and Microbiology. This course will be taught by Professor Sudha Goel and Professor Anjali Pal, myself. We are from the Civil Engineering Department, IIT Kharagpur. We have divided this course into two parts. First part is environmental chemistry, that will be covered by myself, and second part is the environmental microbiology, that will be taught by Professor Sudha Goel. In my first module, I have discussed about the acids, bases and salts. In the second module, I have discussed about the chemical equilibrium. In the third module, I told about the chemical kinetics, and in the fourth module I covered the catalysts. This is my fifth module, and here I will this is my 23rd lecture. Here I will cover the chlorine chemistry and disinfection. This is the part A. Now, in this lecture I will cover disinfection, history of disinfection practices, chlorine chemistry and effect of pH on disinfection. We all know what is disinfection. Okay. So, there is some difference between disinfection and sterilization. We all know that by disinfection we kill the pathogenic bacteria, pathogenic microorganisms, and by sterilization we kill all types of microorganisms. Now, what is pathogens? Pathogens are the disease causing organisms, okay. And what is this? They grow and multiply within the host. We all know that. The resulting growth of microorganisms in a host is called the infection. Under this pandemic, that COVID situation, we all know all those things, we are very much concerned about all those things. Now, pathogens associated with water include bacteria, virus, protozoa and helminth. These things you will know much more elaborately in the environmental microbiology part with Professor Sudha Goel. And here I will just briefly tell you about the disinfection, how we make this process with mainly chlorine and other substance also I will discuss little bit. Anyway, so in the intestinal discharges of an infected individual may contain billions of these pathogens, which if allowed to enter the water supply can cause epidemics. We know epidemics, right? Epidemics, pandemics, and we all know now it is so much important, and endemic also. So, these are the three types. Now, carriers may not even necessarily exhibit symptoms. Asymptomatic means there is no symptom, okay. Exhibit symptoms of the disease, hence more caution should be taken to protect the water. There are many diseases which are waterborne, means water is a carrier for those diseases like typhoid, cholera, these are very common, okay. So, we have to protect our means water supply, the water in the water supply systems, so that this type of contamination does not happen, okay. Otherwise, it will create that epidemics, okay, because a lot of people will drink it and will get epidemics. So, that we should protect. This is our job, environmental engineer job. Now, early history, it has not come in one day, hundreds and hundreds years it took. So, what is the history? This is the early history Okay. So, you will see that this coronavirus, it has come here worldwide, it has come in a very huge way, but this type of thing also happened earlier. Say for example, during 14th century, a plague known as the Black Death broke out in Europe. You know, all the developed countries that time, 25% of the population died, okay, due to this disease, plague. It was called plague. Now, during 1664 to 65, you see that an epidemic swept over London, okay. 14% of the population died, okay. Until 18, I have only told only 2-3, but there are many such occasions, okay. Until 1854, there was no definite idea about the cause of disease, why it happened, why this type of epidemic or plague swept over during that time. The cause was not known, okay, and how it is transmitting from people to people, person to person, okay, that also not known. Because the science of bacteriology was not developed that time. The cause and how it is happening, those things are not, the microorganisms, all those things were not developed. Okay. Now, earlier history of disinfection, this is a very important thing. Okay. John Snow and John York in 1854, they are very famous person. A localized epidemic, Asiatic cholera, broke out in London. The source of infection was water from the Broad Street pump, okay. And the well, why it happened? The well was contaminated by wastewater coming from a house where one person was suffering from the disease. There was actually broken sewer. From the broken sewer, this contamination happened to that pump water, okay. And the broken sewer was carrying the water from another house where one person was suffering from this disease, okay, what is Asiatic cholera. Okay. This was exhaustive scientific studies were done by these two persons, and then they realized that this is a milestone, it is called a milestone. It is realized that there is some relationship like this, human waste, disease, drinking water and disease. So, human waste, drinking water and disease, there is some relation, okay. From this incidence it is known. Now, and slows and filtration started before that 1830, you see that to purify the water. Now, early history of diseases, some important inventions and observation. Now, we know we can use chlorine, we can use ozone, we can use other things to kill the bacteria. The science is developed, but that time we did not know, people did not know this thing. So, early history and some important observation, that is why I collected. The science of bacteriology was originated at 1870, the germ theory of disease was developed. The famous person Robert Koch was able to grow a pure culture of the bacterium causing anthrax in you see the years 1875, then microorganism causing typhoid 1884, Asiatic cholera 1883, and many other diseases were grown in pure culture. So, microorganisms were grown in pure culture, and it was also that time known that water can serve as a major vehicle to transport many diseases. This is another thing that is observed. In 1892, during the cholera epidemic, actual microorganisms causing cholera were found in the river water. So, there was epidemic and the actual microorganism was found in the river water that was used for water supply. That river water was used for the water supply. So, it has come to the water supply. Okay. This is another milestone for the knowledge of waterborne diseases. So, slowly you see how it is developing. Okay. In 1872, the typhoid epidemic in Switzerland was caused by contaminated spring water, okay, and the contamination occurred in a remote place, spring water, so remote place, and then the water travelled underground. However, the microorganisms were still present in the water. So, even if the contamination source is far away, but still it is carried and then it is contaminating the water. These are also very important observations. Now, then it is known that okay, there are some microorganisms that causes the disease and we have to protect our water because it is waterborne disease, and so then what we will do, what practice we will take up, okay, disinfection practice we will take up. What is the disinfection practice? Okay, that time chlorination of water supply was started in 1885 on emergency basis. So, for example, sometimes epidemic started, so the water was treated with chlorine, okay, emergency basis. During epidemic situation, hypochlorite was used, so used for treating water for disinfection purpose, okay. And from 1904 regular chlorine treatment of public water supply was started in England. So, it is no more on emergency basis, regular practice was started, regular treatment was started. After that, from 1908 the treatment was started in the with calcium hypochlorite in many cities of the US in a regular basis, you see. So, people could observe that this is useful thing, disinfection practice is useful. So, they have started the process, and all are chlorine based. You can see hypochlorites, calcium hypochlorite, sodium hypochlorite, chlorine, all those things. So, all are chlorine based. From 1912 treatment of gaseous chlorine with gaseous chlorine started, and from that time chlorination practice has grown very rapidly. So, you can see here typhoid and paratyphoid death rate. So, here you can see that death per this many population. So, you can see here this is the 1900, this is the year, and then you see it is coming down, it is coming down. So, it is 1935, you can see here from here to here it has come. This is some studies were carried out in the US. Okay. From 1912 treatment with gaseous chlorine started, and then chlorination practice has grown very rapidly. As the disinfection with chlorine started in the US, there was a sharp decrease. This is the sharp decrease, sharp decrease in the number of people affected with waterborne disease such as typhoid, as shown in the figure. So, you can see that, so typhoid is a waterborne disease. So, some microorganisms causing this disease is carried in the water. So, if you disinfect the water, then that microorganisms will be killed, will die, and then the water will be safe like this. So, you can see here that slowly chlorination process was taken up. Now, here disinfection practice, you can see that there are two types of curves. Here the typhoid, you can see it is coming down, it is 1946 to 1970. Okay. So, it is coming down from here to here, but here this is a hepatitis, it is not coming down, maybe it is going up, or otherwise at least you can think it is not coming down. Okay. So, why it is so? Because this is the virus causing virus. So, disinfection practice does not is not effective to kill the virus. Okay. Typhoid is caused by bacteria. So, it is it can remove, it can kill those types of microorganisms. Now, here comes the chemistry of chlorination. How chlorine, so what we should use, chlorine we should use or some other hypochlorite we should use, and what is the relation between them, how one form is converted. Here also chlorine chemistry is also very important, because chlorine also can exist in different forms, like it can be as chlorine. So, chlorine gas means chlorine zero oxidation state, it can be as OCl minus, it can be other forms also. So, this is also very important to know. Okay. And also it is means pH dependent, different forms exist according to pH, their concentration varies. Now, what is there? You can see chlorine reacts with water This we have learnt in our school days, that if you allow chlorine to dissolve or to allow to react with water, then it will form HCl and HOCl, hypochlorous acid and hydrochloric acid, hypochlorous acid and hydrochloric acid. And you know the equilibrium expression. So, this is the equilibrium constant. So, K1 is the equilibrium constant for this reaction, and it is nothing but H plus ion concentration into chloride ion concentration by into HOCl concentration by chlorine concentration, and that is nothing but 4 into 10 to the minus 4, okay, at 25 degree centigrade. You know that you have to mention the temperature, because this varies with temperature. Now, the equilibrium predominates. From this you can easily understand that equilibrium predominates in the range of pH 2 to 3 and at the time of chlorine water addition. When you add chlorine in the water, immediately this reaction occurs, and then pH goes down. Okay. And you can understand that because H plus is produced. So, if you can remove the H plus, then slowly the reaction will shift towards the forward direction, is not it. So, if you increase the pH, more and more HOCl will be formed, okay, and chlorine concentration will reduce. Okay. Now, if you increase more, then another reaction will start. What is that? So, that is why it is told that in lower pH this is more predominating. Now, hypochlorous acid means this one, HOCl, is a weak acid. You know that HCl is a strong acid, so it is completely dissociated, but HOCl is a weak acid. So, it is always in equilibrium with H plus and OCl minus. Now, again H plus if you can remove, then more and more OCl minus will be formed from HOCl. Okay. And the equilibrium constant for this reaction is H plus concentration into OCl minus concentration by HOCl concentration, and this is nothing but 2.7 into 10 to the minus 8 at 20 degrees centigrade. Now, from these two reactions you can easily understand that the relative amounts of chlorine, HOCl and OCl minus depend on the pH. Okay. So, at low pH, at very low pH, chlorine will be predominating, medium pH this will be there more maybe, and at higher pH the HOCl will be decomposed to form the OCl minus. So, at higher pH this will be present predominantly. Now, the question is that among these three, which one is the, these are all called free chlorine residuals. Now, actually the question is that which species is disinfecting actually, chlorine or HOCl or OCl minus. Actually all three are disinfecting agent, but HOCl is very efficient. Okay. I will learn more in the that environmental microbiology part, how it is killing the bacteria and all. Anyway, so here distribution of chlorine and hypochlorous acid, the first reaction, if you consider the first reaction, then you can see the pH range, that is why it is selected 0 to 4, and you can see the curve here, percentage of chlorine. So, here 0 and here 100. So, 0%, 100%. Okay. And the percentage of HOCl, it is in opposite direction, 0% and this is 100%. So, if you increase the, as you increase the pH, you see, say for example, at pH 1, you see the concentration of percentage of chlorine is about say 90%, and then this one you see 10%. Okay. As you increase this concentration, means pH, say for example, at pH 2, this is about 50%, this is also about 50%, then at pH 3 the chlorine is say 10% and here it is say 90%, and at pH 4 no chlorine is present, almost 100% it is HOCl. That means that thing I explained in the previous slide, it is following this one. So, pH, with the increase of pH, slowly more and more HOCl you are getting, is not it. So, this is the effect of pH. Why it is important? Because to get the disinfection, what pH you will choose, lower pH or higher pH or medium pH, which pH you will choose, that is the question. And and also if our water has certain pH, at that pH how effective it will be, the disinfection process, that is also important. Now, there is another effect for the this effect of chloride also. So, for example, if you increase the chloride concentration, because sample may be from any place, so chloride concentration may vary also. So, if there is lot of chloride ions present, then what will happen? Once chloride ion is present, so that La-Shuttler principle, so equilibrium will be shifted in this fashion. So, chlorine concentration will be more. That curve I have not shown, but with the variation of chloride ion, how the proportion of chlorine is to HOCl will vary. More chlorine will be there at higher concentration of chloride. Okay. So, how will be the curve? We can draw the curve. I have not shown it, but we can draw the curve here. So, for example, here it is at say 500 milligram per liter chloride concentration. So, if it is 250 milligram per liter, then how will be the curve? That you can think. If you know the equilibrium expression, you can easily think how the curve will vary, okay? Or experimentally you can see and match with your speculation. Now, this is the distribution of hypochlorous acid and hypochlorite ion. This is the second equation that is predominating at higher pH, say for example 4 to 11. Okay. Effect here also effect of pH is there. So, pH you see 4 to 11, and then in this side it is percent HOCl and this side percent OCl minus. So, here you can see from starting from 0 it is 100 and it is opposite direction 0 to 100. Now, so for example, I choose 7 pH. In the 7 pH, at 7 pH you see 80% for example HOCl and 20% is OCl minus, but if you bring it to 9, you see it is maybe below 10% and it is above 90%. Again at 10 it is almost 100% OCl minus. Okay. So, depending on the pH, as you increase the pH, more and more OCl minus is produced. Okay. Now, but OCl minus ion establishes the equilibrium with H plus ion as shown in equilibrium 2. What is equation 2? What is equation 2? You can see here that it is an equilibrium. If you put this one, then also you have seen HI. HI is decomposed to H hydrogen and iodine. If you combine hydrogen and iodine, then also it will produce the HI. If you allow in a closed vessel to reaction to go on, you will either you start from this side or that side, you will get the same composition. So, equilibrium, right. So, equilibrium is like this. So, here also once you start from OCl minus, it will establish the equilibrium like equation 2. It does not matter whether chlorine or HOCl or OCl minus is used, it establishes the same equilibrium. Depending on the pH, it will vary how much proportion of which one is there at how much proportion or concentration. Okay. Now, what are the different things we can use for chlorination? This is calcium hypochlorite, this is sodium hypochlorite. Okay. I remember in our now you can see that that AquaGuard, Kent, that filter, water filter everywhere, even in the restaurants and in the public places, but long time back it was not there. Okay. So, what we used to do long time back, when we used to, especially in monsoon season, when we used to go to some restaurants, before drink we are carrying something which is nothing but zeolite. Okay. Zeolite, and then after going to the restaurant, when we asked for a glass of water, we used to put a few drops of the zeolite there and we wait for some time, then we drink the water. Okay. That why it is so, because it is also sodium hypochlorite certain percentage, and then when we add it, it will disinfect and the water, and then it will be safe for drinking. So, we used in our I remember in our childhood days we used to do this. Okay. Hypochlorites are used as solid or as solutions of NaCl. We can use both, either we can put some solid there in the water during disinfection, or we can make some solution and then we can put proper dose. Chlorine decreases the pH We have seen chlorine when reacts with water, it gives HCl plus HOCl. So, some acids are produced. So, it is decreasing the pH, and when we add the this one, say for example, or this one NaOCl, then it will form Na plus and OCl minus. So, what will be the pH effect? That is again dependent on the equilibrium. Okay. So, it will, if you develop the equilibrium equation, you will see that because it is a salt of NaOCl, it is a salt of weak acid, means HOCl, and strong base, okay, NaOH. So, if it is, if something is salt, some salt is generated from a weak acid and strong base. So, when it is hydrolyzed, so what will be the pH? You all know that, because it is already discussed in the hydrolysis of salt, that is in the first module. Okay. So, that thing happens. So, that is why it is written chlorine decreases the pH, whereas hypochlorite increases the pH of the solution. So, according to the pH of the solution, your disinfection also may vary. Okay. For this, you know the references, Swayam McCarthy, again the same book I am recommending, that Chemistry for Environmental Engineering, very nicely explained all the steps. You can read it more elaborately, it is written there. Now, as conclusion for this lecture, I can tell that to prevent the spread of waterborne diseases, disinfection is commonly used. I have already explained. This has a long history. Now, most common method of disinfection is chlorination. The chemistry of chlorine is very interesting. Hypochlorous acid and hypochlorite produced from chlorine is in water also have disinfection property. The concentrations are pH and temperature dependent. The chloride concentration present in water has also strong influence on it, that I discussed also. Thank you.